Welcome to Maths on Radio, a program catalyzed and supported by National Council for Science and Technology Communication, Department of Science and Technology, New Delhi.
सोचो सीखो बोलो बदलो चमका दो दुनिया को जीत लो इस जहां को
प्रफुल वो वाइडी मेलिसा जेके को मैथ पढ़ा रही है। मुझे तो मैथ का मतलब भी नहीं पता। प्रफुल मैथ मतलब?
मैथ हंसा, वो मेरे ऑफिस के शिंदे भाव की बीवी शिंदे भाव के शर्ट का बटन टूटने पे क्या बोलती है?
वो तो ऐसे कहती है, ओ बाबा तुम्ही ना थांबा, मी आत येऊन लावते। मियात, ओ बाबा मियात। अब प्रफुल और हंसा को मैथ सिखाना हमारे बस की बात नहीं, पर आप सब लोगों के लिए हम ला रहे हैं सुबह 9 बजे, दोपहर 1 बजे एंड शाम को 7 बजे मैथ्स ऑन रेडियो। सुनते रहिए मस्त रेडियो 107.8। Hello listeners, you are listening to 107.8 FM Mast Radio, where you get your daily dose of infotainment. This is our Math on Radio show, Season 2. And I'm RJ Priyal. Today, on our Math on Radio show, we'll talk about derivatives. Derivatives of first order, second order and third order. डरने की जरूरत नहीं है, इसे हम डेली लाइफ में कैसे यूज करेंगे ये भी बताएंगे। मैथ और टेक्नोलॉजी का इस्तेमाल करते हुए हम कैसे बहुत सारे सोशल काम भी कर सकते हैं ये भी सुनेंगे हम।
Hi Shashank.
Hi.
Yes, we heard that you run a NGO called Helping Faceless. Yeah. So could you tell us about it, and also, what exactly this project is all about?
Okay. So, well, it's not an NGO as such. It's an initiative by us, more of an initiative. In early 90s, there was an attempt made to kidnap me when I was a kid, and that has always been at back of mind. I wanted to do something about this, and as with another organizations which take on from there on.
Right. And how about you were working on also trying to trace the probable route of trafficking?
Yeah. So the thing is, once we have enough data, let's say 3-4 years down the line, we have enough data. What we can do is we can predict crime. In essence, that trafficking is a unique crime. It happens at a long duration, let's say a week or 3 days or something like that. Like crime of passion, it has a long duration where you can interrupt and foil the whole plan. Right? There's a supply where if you look at it as a business, there's a supply where the humans, whatever. I'm talking with third person, but
correct.
Yeah. So they have to be taken, and then there's a whole logistics how they travel, and then there's a destination where they reach. Right. So there's a whole elongated plan. So
right.
If we can predict which route they're going to take or which destination are they going to reach, we can foil their plans. We can foil the traffickers' plans. So the idea is to there's this. You might have heard the term big data analytics.
Yes.
It's essentially we use the same algorithms. What we try to predict is using Bayesian probability, that what is the probability of this event happening if this event has already happened at these time durations.
Okay.
So time durations have like if you chart it on a graph on a time series, let's say 2 बजे हुआ, 3 बजे हुआ, 4 बजे हुआ event, and then next day 2 बजे हुआ, 3 बजे हुआ, next day 2 बजे हुआ. So what's the probability of happening at 2? By these 3 data, I can tell कि 2 बजे होना चाहिए probably. There's let's say 80% probability. That sort of thing.
Correct.
So we have time, and if we have time, and if we have event, like we know the event, then we can predict when the event will happen again. So we need lot of data for that. So what we do is so the missing children are generally trafficked. I mean, some of them run away, obviously. But our assumption is, or rather from the stats at least, from the NCRB stats, National Crime Stats, around 60-70% of these children are trafficked.
Okay.
So assuming that, what we do is we take the place they went missing from, the time they went missing from, and when they reappeared, like they were found somewhere else. Right. So we try answering the root question, like this is the lat long they went missing from, and this is lat long they reappeared. And if we have enough data from both ends, we can try figuring out the route, or at least the time taken.
Time at least, which will be in fact a great help in the situation whatever we have now.
Yeah.
Absolutely.
So there's another side to the story also. Not only on that end, but all these trafficking rings or the begging rings have a certain business model, right? You'll always see a child sitting next to a maternity hospital. Right. This sort of things have certain sellability, if you will. It's a very crude term, but sorry, I have to use it. Certain people have certain sellability. So jiska haath toota hua hai, handicapped hai, and if he's a kid, you will generally find them near child hospitals because they evoke that sort of emotion, and people are more prone to give money to them.
Correct.
Right. So they understand the sellability, and so that's why these people are rotated. Even though they are rotated every week or 2 weeks, they haunt the same places. They are rotated on the same places. Like if they are 10 children, let's say there are 10 children hospitals, so they'll be rotated in these 10. So if we can, using our data, we can predict where they'll go next.
We can probably find them.
So the same algorithm, same thing. If you know the event and it occurs n times, can you predict n+1 time when will it occur?
Correct.
So you can just answer when, how, and where.
Yes. Shashank, thank you very much. We wish you all the very best.
Thank you,
and we hope that you keep on doing some good work all the time.
Thank you, man. Thanks a lot.
Shashank. Thank you.
तो सुना आपने कैसे हेल्पिंग फेसलेस प्रोजेक्ट में टेक्नोलॉजी और मैथमेटिक्स यूज करके एक एंड्रॉइड ऐप क्रिएट किया गया है। शशांक सिंह कैसे प्रोबेबिलिटी, डेटा एनालिसिस, सैम्पलिंग, मैट्रिक्स, फेस रिकॉग्निशन एल्गोरिथम्स जैसे मैथ कॉन्सेप्ट्स यूज करके बच्चों की मदद करना चाहते हैं। The definition of derivatives goes this way. The derivative of a function of a real variable measures the sensitivity to change of a quantity which is determined by another quantity. Don't worry friends, though the definition sounds so abstract, we use a lot of derivatives in our daily life. To know more about how we use these derivatives in our daily life, let's listen to Sushil Torne. He is a research fellow at the Department of Economics at the University of Mumbai.
Hello friends, welcome back to Maths on Radio. I'm Pankaj and with me my friend Sushil is there. Sushil, in this Maths on Radio program, we try to talk about maths, but I'm really not sure that do we really use mathematics in daily life?
Like we are here today to talk about calculus.
Calculus?
Yes, and I think we use calculus in our daily life.
What do you mean? Calculus, of course I've learnt it in school, college and my engineering days, but how do you use it in daily life? I thought it was just theory and theory and theory.
Pankaj, what's the time right now?
It's 25 minutes past 3 o'clock.
So 25 minutes. Can you tell me the spelling of minutes?
M-I-N-U-T-E-S.
And can you tell me the spelling of minutes?
M-I-N-U-T-E-S.
So why do you say minutes and minutes? What's the difference?
Minutes probably are for time and minutes are for maybe a meeting.
Okay, so now when the time is 3 hours and 25 minutes, it means that with respect to the whole day,
right?
It's 3 hours and there are 25 minute parts of the third hour. And how many seconds are there right now?
About 30.
So why do we say seconds?
Because that's the unit after minute. So 60 seconds make a minute, that's why.
So when you say 3 hours, 25 minutes and 30 seconds, we are giving 3 hours, 25 minutes are 25 minute parts of the 3 hours, which means it's a first order derivative, and the second order derivative is just 30 seconds. So second got a name from the second order derivative of the hours.
Oh, so that's why we say, but then do you call it minutes or minutes?
It's minute. Our forefathers said minutes, but evolution and not evolution, but we evolved saying in minutes.
So the actual use of the word or pronunciation is minutes.
Minutes.
3 hours and these minute parts of an hour.
Yes, and then the second order derivative of the 3 hour becomes a second.
And that's why you say 10 seconds, 20 seconds, 30
Exactly.
seconds.
That's a second order derivative of an hour.
That means
so we
people
calculate
use-
everything with respect to hour, because this is what our forefathers said, like forefathers did.
Oh, so we use it in everyday life, and
Exactly.
still we don't know its importance.
Exactly. And by the way, this is the method which I'm talking right now is the Lebesgue method.
Lebesgue method.
Yes, because there are two methods.
Uh-huh.
One is a Newtonian method, and
Uh-huh.
the second is a Lebesgue method.
Okay.
The in Newtonian method, normally the Englishmen, they say, like 3 o'clock.
Oh,
So when they say 3 o'clock, O means a 0.
okay.
So when the shorthand is on 3rd, and the big hand is on 12th, the 12th hand, which is on 12, the slope is counted as 0. That's a geometric method
Okay.
of saying 3
Oh,
o'clock.
that means it's 3.
I'm counting the slope as O, which is 0,
Uh-huh.
and it's clock.
This is amazing. I mean, we look at the watch almost at least 10 to 15 times in a
Yes.
day, but we probably don't understand the background behind it. It's all
Yes,
mathematics.
It's all mathematics. It's basically derivatives, and it's basically calculus. Calculus is like a minute change, a very minute change with respect to an hour. But to tell you to be very frank, it's all relative.
It's all relative.
Yeah, because if you say, because the thumb rule is an hour is counted out. But if you are a physicist, then you'll count the microseconds, and so the second order derivative would be of some pectoseconds
Okay.
or some nanoseconds.
Mm-hmm.
So that's again relative. But in normal terms, normally we use these kind of frameworks.
So it's minutes, and it has now become minutes,
Yes.
and it's seconds because it's the second
order derivative
of the hour,
hour.
and that's why you say so many seconds.
Yes.
So 60 seconds make up a minute, which is known as a minute now.
Yes.
60 minutes or 60 minutes make an hour,
Yes.
and 24 hours make a day.
Yes. And to be very precise in calculus terms, I would say 1 minute
To be precise.
to be precise.
So it's simple.
And then 1 second would be 1 upon 36,000 parts of an hour.
Yes, because 60
Sorry,
seconds.
3,600.
Yes, 3,600. That's right.
Yeah.
So 1 hour is 60 minutes.
Yes.
1 minute is 60 seconds.
Yes.
So an hour is 60 into 60.
Yes.
That's 3,600
So 3,600
parts.
minute, double minutes and minute parts, second minute parts of an hour.
So it's not actually difficult, So why do you
No.
think people are so confused? Only because of the language. Probably they don't understand. As you said, there's the Newtonian method. The Britishers would say 3 o'clock, and the other
This is basically the German method.
Lebesgue method.
Yeah.
So is it only because the language weighs on you and we don't understand simple logic of the mathematics?
Yes, because we have taught to understand language of mathematics in symbols, and these symbols are universal. So if I write a mathematical paper right now, so people, even if I write, say, German, and another mathematician from other part of the world reads the equation, he understands it.
Exactly. So it's
So that's basically a language. So you should see maths as a language.
exactly. So
Simple.
probably we can also say that mathematics is one of the most common languages across the whole world.
Yes, it's a universal language.
Absolutely. Stay tuned to more maths updates on 107.8 FM.
So in our today's episode on Math on Radio Season 2, we heard how probability, data analysis, sampling, matrix, and face recognition algorithms can be used for a social cause too. We heard from Shanshank Singh how an Android application can be created with the help of technology and mathematics. We also heard about derivations. Though they might sound like a complex concept, we use them a lot in our day-to-day life. And so Math on Radio Season 2 is here to simplify all such complex math concepts for you. I'm sure you liked our today's show, so do send us a feedback on our email ID, radiomust@gmail.com. That is radiomust@gmail.com. And do like our Facebook page for our regular updates.
நீங்க கேட்டுக்கொண்டிருப்பது மும்பை பல்கலைக்கழகம் மாணவர் ஒலிபரப்பு ரேடியோ மஸ்ட் 107.8 FM. Maths on Radio, a program catalyzed and supported by National Council for Science and Technology Communication, Department of Science and Technology, New Delhi.